Perfect. So let's look into this today's last class with regard to Aprov. I just want to give a summary of it. Okay, summary of it. I think we have done a little bit more compared to what VTU will ask, but that's how things should be. Okay, so there's no point just running to the syllabus and all. That can be done in a very faster way. There's no point of doing that only that much, right? So this is the summary of what I'm supposed to get. We talk about association analysis. We come across a term called frequent items. Okay, what frequent items? Because association analysis always deals with that. You need to figure out what are the two frequent items, three frequent items that are coming together. So to figure out that, when the size of the data is too big, when you think this will become tough? Okay, there's something called tough that is written here. So when do you think that will become tough? It will become tough when the data size is too big, right? This will become tough only when the data size is too big. So then you come across all these techniques of pruning, Aprov, reduce the comparisons, everything. Okay, this is very important because that is there for your syllabus. The number of comparison, reducing the number of comparisons basically is nothing but a part of this one. Okay, then of course after Aprov you have something called as rule generation, because this Aprov is just one part of it. Okay, just one part of it. The next part is all about rule generation that probably you're going to see in the next classes to come. Okay, so but what about exam? That's very important. Okay, so people may have this doubt of what needs to be done with regard to exam. The question will be coming in a very simplistic feature. Sweet you, right? So it's always going to come in a very simplistic feature. First thing is, they are going to ask you what is an Aprov algorithm, or write an Aprov algorithm. That's what they are going to ask you. For that, I'm pretty sure you guys know the answer for it. Okay, so the Aprov algorithm needs to be written. That's the first step. The next thing, you need to take one example and you need to sort of write for it. Okay, so there's two ways of doing it. One, you're going to write an Aprov algorithm followed by an example. Or what is the other way of asking it? The other way of asking is very simple. They themselves are going to give you an example. And when I say they themselves are going to give an example, 90% of the times it is that market basket analysis problem. I think we are going to see that today again for the very last time before we move into rules generation. Okay. So that what is the problem they give? They give this problem of market basket analysis problem, where they have these 5 transactions, bread, milk, all those things related to it, that they are going to give you, and you are supposed to sort of implement. That's very important. You are sort of implement the Aprov algorithm. They may ask you what is the Aprov algorithm. You have to write it down. What is the Aprov algorithm? 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 Okay, hopefully you're back. Uh, Again, sorry for the disturbance. Again, it's internet infrastructure in India, right? So can't help. Okay. Now, with regard to this algorithm, right? So what is the thing that they may ask with an algorithm? The problem with this algorithm is it's too tough when you sort of see the understanding part of it. But of course, it's more understandable if you see only the lines, which is only 14 lines. Of course, you write bigger programs when it comes to file structures. Okay, so I don't think so. 14 lines is that big a problem. Okay, I think probably in ST you have very small programs, but in file structures you have very big programs, right? So that should not be a problem. Okay, probably you are going to start the lab sessions from today, right? So that's something that you got to keep in mind. Okay, this algorithm I have put it in very simple words also. I think you are going to see today. What is that simple words? We are going to going to put it in sort of a steps, okay, or more like a pseudocode and all. That also I have put it in the PPT. There will be an algorithm also. You have put the steps also. You're not supposed to write steps. You're supposed to write only the algorithm. But I've made it in a point where everything will be there. Maximum amount of data that related to it will be there with regard to the advantages, disadvantages, everything. That's all not there. Okay, but it's always good that you sort of get to know it. Okay, so this is with regard to the what is known as the exam point of view. Okay, the exam point of view, these are the things to be kept in mind. Algorithm, the examples, and of course, if they ask an example, then you need to implement an Aprov algorithm for it. Okay, all these things comes under a topic of your association analysis. Okay, now what is the next thing? Okay, what is the next thing? You are going to see one example again. Okay, with regard to, but before that, we are going to look into the Aprov algorithm. Okay, this again, looking at the algorithm, many people will think how to sort of remember this. I know it looks very tough because there's a lot of mathematical notations involved in this. Okay, but you sort of understand the steps and then you come back to it, probably it will not be an issue. First and foremost, how you need to remember this? Okay, you need to remember that there are 14 lines. So I am talking from point of view of a evaluator. Okay, how a person who is going to evaluate your paper is going to look for. You're supposed to look for 14 lines. There are 14 lines in it. Okay, then the next thing is you need to start from k is equal to 1. Now, what is the meaning of k is equal to 1 is first step is what is the first step every time we do? We are going to take, you can see very clearly here. Okay, what are steps in Aprov algorithm? Okay, you can see this Aprov algorithm is a sequence of steps to be followed to find the most frequent item set in the given database. Okay, see the underlining part is still not done. Okay, because this PPT is still in a raw stage. I'm going to, of course, before I send, I'll be sending the finished product, which will be having all the underlined, the bold part, everything and all. I'll be sending it. Okay, not a worry. So what's the next thing? The second thing is the data mining. This data mining technique follows what? Joining and prune steps iteratively. What's the meaning of joining and prune steps? You're going to keep on combining one item set, two item set, three item set like that. That's called join. And you're going to talk about the prune thing, which is nothing but whatever, if the minimum support is anything less than, sorry, if the number of frequent item set is anything less than the minimum number of set, what do? You take out that. That's called pruning, taking out or removing. Okay, iteratively until the most frequent item set is achieved. Okay, then the next part, the minimum support threshold is in the problem. It will be either taken into consideration as an assumption or it will already be there in the problem. What happens in exam? That's very important. Exam they're going to give you, or you can assume as 2. Generally go with 2 or 3, not more than that. Okay, not more than that, not less than that. 2 or 3. These two things should be kept in mind. Okay, you are going to take the minimum support as 2, or you are going to take the minimum support as 3. In the problem, in the exam, if they are not given that exclusively, generally they'll give, because they don't want any sort of assumption, because again people come with different skills for evaluations, right? There may be people who don't even know the subject but they correct it. Okay, so to avoid that, if some people take 2, some people take 3, in what is the scheme that will be written? The scheme will be written in such a way that okay, if they take 2, this is the value. If they take 3, like this is the value. And some people may take even 4. So to avoid that, so that if they do that, the scheme itself will become very big. To avoid that, what they do, they themselves are going to give. Okay, the minimum support count, they themselves going to give. So it should not be a problem. Okay, so what is the step? Step number 1, what is the thing you do? In the first iteration of an algorithm, each item is taken as a one item set candidate. Okay, then the algorithm will count the occurrences of each item. That is what you see right in this step number 1. K is equal to 1. And then what is the next thing? You are going to figure out all one item set, for frequent one item sets candidates. How we are going to do it? Fk. What is Fk? K will value will be taken it as 1. Okay. You are going to take for 1 where 1 belongs to your item sets. Okay. Figure out all those things which have a support of more than whatever the minimum support that is given. That is what you see in the first line here. Okay. That's what you see in the first line. This, I know, it's seeing the mathematical notation, you get confused. Okay. Or you think it's tough. But when you understand the value of it, see, for only for writing this algorithm, this is needed. Okay. But when you want to implement an algorithm, you don't have to see this. You know what is the steps. You know the understandable way of steps. Using that, you can sort of work through it. Okay. So that's very important. What's the next thing? You keep on repeating this. Okay. You keep on repeating this using the step thing called k is equal to k plus 1. So first you're going to take k is equal to 1. Then the next thing is 2 item set. The next thing is 3 item set, like that. So along with that, you are generating the candidate item sets also. How? Using CK. K value will be taken as 1. So you saw in the previous example yesterday itself you saw. First you calculate C, with regard to L1, F1 like that. Then you figure out C1, which is nothing but Aprov generation algorithm. Okay. Then for each transaction, you will be keep on doing that. Okay. Figuring out the subsets of it for each and every time and increment every time. Okay. See, only up to here, I think you have to somehow need to figure out. Then it is all about, you can see very clearly how you need to remember this. It's a very, very important question. It will come for your interns. Okay, because I want you people to write it. So you can see, the line number 10, line number 11, everything is end for. Okay, these things will not be a problem. 14 lines will fetch you more than 5 marks. So that you got to keep in mind. Okay, so it's a very high scoring prospect. What is the next thing? Okay, you can see, let's go back to our steps. Where is the steps? Yeah, let's go back to step number 2. What is it? Let there be some minimum support, which is, example we've taken as 2, generally 2 only, 2 or 3. If there is lot of transactions now, we take 3. There is generally 5 transactions and all, we go with 2. Okay, and it's a very good prospect that you sort of remember that basket analysis. Okay, problem with transactions, with items and all. If you can remember that, probably you can easily put into consideration, because you are supposed to know that previous examples of whatever you learned with regard to my association analysis, that examples need to be kept in mind. Okay, so that should not be forgotten. We are going to see that for a very last time today. Okay, now let's look into this. Okay, let there be some minimum support. Example, we are going to take it as 2. Okay, so set of 1 item sets whose occurrence is satisfying the main minimum support are determined. Okay, then only those candidates whose count more than or equal to minimum support. So it should be either more than or equal to minimum support, are taken ahead. Okay, are taken ahead for the next iteration. And others are very much pruned, which basically means others will be taken off, others will be removed. Okay, what's the next thing? Step number 3. Next, 2 item set frequent sets with a minimum support are discovered. This is for 1, this is for 2. For this again, for this to be in again, 2 item set is generated by forming a group of 2 by combining itself. Okay, so we're going to take one again. We are going to take an example for it, and probably we're going to figure out. Okay, very last time I'm going to look into Aprov algorithm. Okay, so it's more like a summation I'm trying to give. We took close to 4 examples with regard to Aprov algorithm, different examples, but at the end you come up to this. Okay, you come up to this. Why? Because 90%, I was telling you the same thing. 90% of the times, with you guys will go with this example. Why? Because it's a standard textbook example. It's a standard textbook example. People want you to learn the textbook, right? So let's look into this. Okay, this table, I want you to be sort of remembering it. Without forgetting it, you must know this. Okay, if you are able to know this, later parts of the steps all become very easy. And you can see what is the support we have taken. The support, minimum support here, we have taken it as 3. You can also remember with the same old example with regard to 3. Okay. See, if every subset is considered, what is the number of items do we have? We have the number of items as equal to 6. So if all the subsets are considered, 6C1, taking one item at a time. Please understand this. Okay. So taking one at a time among 6 items. Taking two items at a time, 6C2. Taking 3 items at a time, 6C3. Now you may be thinking, what about 4 items? See, the maximum number of transactions, the width of a transaction. Okay, the width of a transaction is 4. Okay, there's 4. So you will never have a minimum support of more than, you can see 1, 2, 3, 4. There are 4 transactions and the maximum length is 4 only. You will never have a minimum support of more than 300. Never possible. There is 5, maybe. If the width is more than 5, maybe probably it's possible. Otherwise, always remember, whatever the width you have, the maximum width. In this case, you have the maximum width as 4. The number of frequent item sets you are going to take will be 1 less than that. So it is 4, you're going to take up to 3. Okay, up to 3. Even the minimum support, it will be either 3 or 2 or 1. Like that only you need to take. You're not supposed to take 4. You take 4 also, it will not be working on that. It will become 0, it will not be an issue. Okay, now you can see if you take without Aprov principle, that's what they want to say here. Okay, without Aprov principle, if they try to do it, this is the number of combinations you are supposed to get. 6C1, 6C2, 6C3. What is important here? Remember the main, the top approach. What is the top approach? The one what you see on top, right? See, there are 6 items here. Okay, there are 6 items here, and every time you are taking 6C1, which basically means you are going to take one item at a time. And what is the number of combinations you get? Okay, then again the same old 6 items will come for taking 2 items at a time. What is the number of value you get? The same old items of 6 will come for taking 3 items at a time. What is the value you get? Okay, what is 6C2? You can see very clearly in the slide that is given. Okay, 15 and 20. So I can write the same thing with regard to these values. What is the value? 15, 20. Now what is this? This is the number of, be careful here, this is where it becomes very important, number of frequent item sets. They are nothing but item sets only. They are frequent item sets only. The number of frequent item sets, the one which is very important, the line which I'm going to write now, without, okay, without Aprov. This is the number of combinations you get. Okay, don't see the handwriting, understand the wordings. Okay, without Aprov, what is the number of combinations you're going to get? What's the number of combinations you get from it? 20, 35, 41. You get 41 frequent item sets without Aprov. That's very important. Okay, but if you implement Aprov, okay, if you implement Aprov, what is the number of combinations you're supposed to get? So I'll write that and then I'll show you also. Okay, for the very last time, I'm going to show you what is that, the number of combinations you're supposed to get and all with Aprov. This is very important. This is with regard to with Aprov principle. Okay, what is the number of combinations? Obviously, the first item sets will not change. 6 items are there. So you are going to take with 6 items, taking one at a time. You are going to get 6. Not an issue, not a problem. But when you come to the second iteration, okay, when you come to the second iteration, the number of items that are there in 6 that was, initially will sort of reduce to what you can see very clearly in the slide. Okay, what is the number of items? Where is it? Yeah, the number of items that will be coming through will be reducing it to what you can see very clearly with support based pruning, that will be coming down. How it will be coming down? Let's see that. Okay, now you see this example. This is with regard to without Aprov principle, you are getting 41, not at all an issue. With support based pruning, they're saying you get up to 16. Okay, fine. We don't want to sort of learn about that. You don't worry about this why it's coming through about support based pruning and all. Support based pruning. Okay, you write this. You must be remembering this diagram, right? This is with regard to support based pruning and all. The diamond type structure, everything. It's very difficult to do. It's very tough task. Manual version of it, brute force method. Okay, that you don't worry. We are going to worry about the Aprov principle that we are going to see. This is my transaction. I'm going to take one at a time, and this is the count 4, 2, 4, 3, 4, 1 and all. My minimum support is 3. I've taken minimum support as 3. Okay, that's something that you need to keep in mind here. Okay, once again, I'll zoom in. Yeah. See, my minimum support, I need to take it as what? I need to take it as with regard to 3. So this is items with regard to if I take one at a time. Then if I go for the next one, okay? If I do what is known as taking the elements, taking out the or pruning the elements which have the minimum support of what? Less than 3. What is going to happen? Coke and X will go, because they are only coming up only up to 2 times and 1 time respectively. Coke and eggs will go. Okay, so when I'm taking the 2 items at a time, what is the number of items I need to worry about? Bread, milk, beer, diaper. How many things? 4. It is not 6, it is 4. Okay, it is not 6, it is basically equal to 4. So what is my next step? See this? That's what I'm trying to do here. I have taken out 2 pair items. There's no need for me to generate candidates involving Coke and X. I've thrown it out. Okay, I've thrown that out. What is my next step? What is my next step? Next step is to make sure that I am going to look into this again. Okay, see, I'm going to take 2 items at a time now, with along with their count. Okay, here there was no count. You can see very clearly there was no count with regard to whatever the 2 items I have taken. But here I'll go get the count. Okay, in the next step I'm going to get the count. You can see very clearly what is the count: 3, 2, 3, 2, 3, 3 and all. Okay, so I got my count. What is my next thing again? Minimum support is 3. So I'll be taking it out this BM bread and BM milk. So if I do that, you can see very clearly that triplets. When I got that triplets into consideration, this is what I got. I'm going to take these 2 things out. 1, 2, 3, 4. 4 only will remain when I take 2 at a time. And then when I take triplets at a time. Beer, diaper, milk, all those things with their count. See the count? 2, 2, 2, 1. Okay, with their count if I take, now you see the number of combinations I got. The number of combinations with my support based pruning comes up to around what? It comes up to, if I take with regard to these things, right? So if what are the support count that is there? The support count is only 3, and I have got, do I got anything related to it? No. So support count comes up to around what? It comes up to around 13. From 41, it basically comes up to around 13. Okay, so you can see the same old thing that's been written here. Okay, in a very simplest of fashion, you can see step number 2, you're going to look into 2 item sets. Going to take 2 item sets. Okay, then step number 4, the 2 item set candidates are pruned using minimum support threshold value. Now the table will have 2 item sets with minimum support only. Fine. Step number 5, the next iteration will form 3 item sets using the join and prune step. Okay. The things that you have. Okay. So yeah, I think we are back. Okay, let's look into this. This iteration we clearly says that unitone monotone property, where the subsets of 3 items, that is 2 subsets of each, I fall under the minimum support group. Okay, if all 2 item subsets are frequent, then the super subset will have frequent. Otherwise, it is prone. Okay, at the end you come up to this one. So I put it in very simple steps. There are 2 things of it. One, there was an algorithm. I have made that as a what you call as a step-by-step procedure. Okay, for you to sort of understand the algorithm, maybe okay. So hopefully you are back again. See, there's some problem. Okay, can't help it. Can't change also certain things, certain people. Okay, you can see this. I have put it in terms of the algorithm is been put in terms of steps, manual way of understanding steps, and also in the other way. What is the other way? The other way is nothing but I put it in form of a flow chart also. You have got an item set, you are figuring out the k item set candidates using the joint step, then you're doing what is known as the pruning thing, taking out the ones which have the minimum support, and then we going into again frequent item sets. Again we are doing for with regard to k minus item sets, we are doing what is known as figuring out the the frequent item sets, and if yes, we are going to stop it, otherwise we are going to keep on going with a loop like this. Okay, this is a loop. So for anything, you can always write an algorithm. For anything, you can always write a flowchart, right? Especially the computer engineers, they should be able to write a flowchart for each and everything. Okay, that's what people teach you right in maybe in your first year. That okay, this is step number 1. This is what you do. Then the flowchart aspect of it. Okay, algorithms and flowchart becomes very important at that point of view. Okay, so this basically comes up to around what is known as the way of understanding your Aprilia algorithms under. Okay, so where do you think this all can be sort of implemented under? They can be implemented in many ways, in many fields. Okay, right from your education field, what do you do in education field? You are going to extract the rules of admitted students to characteristics and specialities. You may not understand this. I'll tell even simpler sort of example. We can sort of associate students with their locations, and we do it even in our college. We do it. We sort of associate students with their locations. Okay, so what we do is majority of our students from SUC, they basically come from the district of Chikbalapur. Okay, we got the places from Chikbalapur, Shrigatta, Bagipulli, all these places. Okay, Dodbalapur, these places that are associated with students. That's association analysis. There's location, there's students. Students, if you can sort of pick up these locations, there's a good number of students who are going to come. And of course, towards Bangalore side, you have Yelanka and of course IAF, Indian Air Force. Okay, that's when it comes to education field. Maybe in medical field, analysis of patient's database. Okay, forestry, analysis of probability and intensity of forest fires with forest fire data. Where do you think a forest fire will generally happen every year? Every year during summers, there are certain areas in India where the amount of forest fires happen every time. Okay, when you go to Karnataka, there's this northern part of Karnataka, and of course in Bandipur, where these fires will generally happen, Okay, either due to the negligence of human trafficking thing, or the natural fires, because it's too hot, the vegetation is too dry, and it starts to get burnt out. Okay, it's a natural process. But if it's too big of fire, okay, maybe a fire that happens in maybe probably I don't know how many of you seen the news on a fire that happens in Australia or in Brazil, which is too big and it will cause a lot of problem to the ecosystems. Those things can be sort of understood from the association analysis. Where is the fire happening and how you need to sort of figure out that. Okay, and of course, Aprov algorithms can be used by companies like Amazon, Google for figuring out the recommendation part. Okay, the recommendation part and all can be easily sort of understood right from your Aprov algorithm and all. Okay, these are things that to be kept in mind. Okay, I think it's all time up. Okay, I'm not supposed to take more than 30-35 minutes. I don't know, that was one of our suggestions. Okay, so yeah, fine. Anyway, in the next class, we are going to deal with the next part of it, which is with regard to rules generation. Very important aspect of it. Okay, after frequent item sets in that Aprov, the next part is obviously rules generation. How do you going to generate rules for this Aprov algorithm? So there's two parts of it.